All right, so the last little piece of Lecture 17. We've talked about what acids are and what bases are. The last piece is sometimes you have things that we call salts. Salt is just another word for any ionic compound, more or less. But salts can be acidic or basic, and it takes a little bit of skill to be able to look at a given salt, look at the chemical formula and say, oh, that's going to be acidic, or that's going to be basic, or that's going to be neutral. Okay? So this last little tiny piece is just going to address that. The key is a salt is made of a positive ion and a negative ion. Positive ions are sometimes acidic. We've seen a couple examples of acidic positive ions. All right? The most common one is going to be NH4+, ammonium. And with ammonium, it's relatively obvious where the H plus comes from. So NH4+, remember an acid is a proton donor, an H plus donor. NH4+, oh, it's got H plus, so it can give an H plus away. So that can be acidic. Certain metal ions are also somewhat acidic. We talked about that way back when. Let's see. We talked about how a metal ion might be acidic way back when, I think in the first lecture, we talked about how aluminum 3+, when you dissolve it in water. Turns out aluminum 3+ is very attractive to water, because water's got the partial negative on the oxygen, they've got lone pairs, and so the water molecules, because aluminum has a positive 3 charge, and it's very, very small, very compact, it pulls those water molecules in, and we said it pulls on the electrons from the oxygen enough to make one of these hydrogens fall off. All right, so aluminum 3+ can bond with water, make AlH2O6 3+, and then that can lose a proton. So there are some positive ions that are acidic. The other thing is a negative ion might be basic. So a negative ion could be basic. Well, why might a negative ion be basic? Well, what's our definition of a base? It accepts H+. So if you have a negative charge, you're kind of in prime position to accept H+, because then that'll make you neutral. So things with a negative charge might be basic. All right? And so we need some guidelines. For cations, here's what I want you to remember. I want you to know that NH4+ is acidic. It's relatively obvious how NH4+ can be acidic. So you definitely need to know this one. But if you have NH4+, it can split up into H+ plus NH3. As far as the metal ions go, I don't want you to have to memorize a list of those. So you should be aware that some metal ions can be acidic, but you don't need to memorize. So as far as looking at a salt and identifying the cation as being acidic, you ask yourself one question. Is the cation NH4+? No? Okay. The cation is not acidic. All right. Most other metal ions, not acidic. Then for negative ions might be basic. And there's a simple way to spot if they're basic or not. There are only a few negative ions that are not basic. And those Negative ions that are not basic would be the conjugate bases of strong acids. You may remember back when we talked about acid strength and strength of conjugate pairs. If something's a strong acid, what does that mean about what it does with its proton when you put it in water? Breaks up easily. So if you're a strong acid, that means as soon as you put it in water, it just throws the proton away, wants nothing to do with it. That means that negative ion, that conjugate base, is going to be completely non-basic. So non-basic anions would be the conjugate bases of strong acids. So we could list those. Our strong acids were HCl, HBr, HI, HNO3, H2SO4, and then there were the chlorate ones. I said I don't even care if you remember those. The first 5 are the more important ones. So what would my non-basic anions be? What would be one example? Cl minus. What else? SO4 2 minus. Actually, not exactly SO4 2 minus, although SO4 2 minus is more or less non-basic. It's very slightly basic because for H2SO4, only the first proton fully dissociates and the second one only partially. So the second dissociation is a weak acid. So I would say HSO4 minus. But if you said SO4 2 minus, I'd say that's acceptable here, but not 100% right. Cl minus, HSO4 minus, Br minus, I minus, and NO3 minus, yeah. And then the other two that I said, I'm not as concerned that you remember these, ClO3 minus and ClO4 minus. So any anion that's not one of those is basic. So basically you have a few cations that are acidic, and then everything else is not acidic. And you have a few anions that are not basic, and everything else is basic. So when you look at a salt, you want to first split it into the positive ion and the negative ion. Ask yourself, is the positive ion acidic? Is the negative ion basic? And then decide, all right, is the salt overall going to be acidic or basic or neutral? So to take a couple examples, NH4 plus, what 2 ions would I split that into? All right, one way to think of this, and I'm gonna list this as a separate way, would be to think of this as a combination of NH3 and HCl. I'm gonna come back to that in a minute, because mentally that is a way you can approach it. But if I were to just think of this as an ionic compound, what 2 ions would I say it's made of? NH4 plus and Cl minus. So NH4 plus and Cl minus. So I would ask myself, is NH4 plus acidic or not? Solly? It is acidic. Is Cl minus basic or not? It's not basic because it's one of our ones on the list of non-basic anions. It's the conjugate base of a super strong acid, which means it's super weak. So this is not basic. So if I combine something that's acidic with something that's not basic, the overall result is this salt is acidic. All right, so the student question is, what if there's something that is slightly acidic and something that is slightly basic? We'll get to an example like that. But that's actually pretty rare and not a situation we're actually going to ask you to do on a test or anything. But there is an example in here like that. So for NH4Cl, another approach would be to think of NH4Cl as being a combination of NH3 and HCl. All right, so this is an alternative approach. Is to think of it as an acid and a base. So what do we know about HCl? What kind of acid is that? It's a strong acid. What do we know about NH3? Well, it's not an acid, it's a base. If you look back in your notes a little bit where we talked about bases and the difference between strong bases and weak bases. NH3 is our classic example of a weak base. So if you have a combination of a strong acid and a weak base, what would that tell you about the combination? Who wins? The acid. So strong acid plus weak base. This is, leads to the same conclusion. So you can think of it that way. All right, this next one with spring training right around the corner might make us think of happier, warmer times. RBI. It's a baseball reference, if you didn't catch it. What two ions is RBI made from? All right, so this one is made from rubidium plus, so Rb plus, and I minus. So Rb plus, is that an acidic cation? Well, it's not NH4 plus, and it's not Fe3 plus or Al3 plus. So no, it's not acidic. I minus, is that a basic anion? Nope. So you put together something that's not acidic and something that's not basic, and you get something that's neutral. All right. Process makes sense. So try these next two. Split them up into the ions, evaluate each ion. Okay, K plus. Is K plus acidic? Nope. Is acetate basic? Yes, because acetic acid is not a strong acid. So this is basic. So put them together, and this salt is basic. All right, and then NH4 plus, we've already established this is acidic. F minus, is that going to be basic? Yes, because it's not on this list. It's not one of these anions. It's a conjugate base of a strong acid, so F minus is basic. So the question here is who wins? And honestly, whoever wins is only going to win by a little bit anyway. So this is going to be very close to neutral. But you could figure out who wins by comparing the acid strength and the base strength. So to tell who wins, compare Ka of NH4 plus to Kb of F minus. whichever one is bigger, that one's going to win. Turns out in this case, NH4 plus is just slightly more acidic. But this is not a situation I expect you to have to do on a test or anything. Maybe there's a couple examples on a problem set. All right, what questions do you have about how to tell if a salt is acidic, basic, or neutral? All right, so the question is, why is it that HF is not a strong acid, but HCl is, and HBr is? So that's part of lecture 17.4, which you guys didn't see in class. But when you watch lecture 17.4, we talk about trends in acidity. And turns out you have hydrogen bonded to different elements. If the element hydrogen's bonded to is bigger, that tends to make the acid get stronger. And part of the reason for that is the bond between hydrogen and that element is weaker when there's not as good overlap between the orbitals. So hydrogen's this really tiny orbital. When it tries to bond with chlorine or bromine or iodine, is trying to overlap with these much bigger orbitals. And that weakens that bond and makes it a little easier to break the H plus off. The other explanation we give for it is we say that the negative charge being spread out on the anion helps stabilize the negative charge. So again, iodide, because it's got the negative charge has so much space to spread out because it's so big, that's a stabilizing factor. So as you go down the periodic table, acid strength tends to increase. All right, we'll call it a day there.